Morning, everyone. We're going to take a look at our next lesson in the Permutations Combinations unit. And the title of today's lesson is Arrangements of a Set of Objects when some of the objects are alike. Super important. Some of the objects are going to be alike. Okay, so before we start, let's look at some classic letter examples. And let me read the instructions. How many unique words, arrangements of the letters, can be formed using the following letters? So if we look at the letters TEA, classic letter example, we've done a ton of them now. 3 letters being dropped into the beautiful cloth bag being shook. How many choices do I have for the first pull? Take the letter out, display it on my desk. How many choices do I have for the second pull? Take the letter out, display it on my desk. How many choices do I have for the final pull? Final answer, 6 different options. If I look at the letters in the word meat, M-E-A-T, all of them being unique, how many choices do I have on the first pull? How many choices on the second pull? How many choices on the third pull? How many choices on the fourth pull? Very, very standard. These should be very kind of standard, easy, 1 mark type of questions. In the word carpet, there are 6 letters. So again, how many choices on the first pull? How many choices? How many choices? How many choices? How many choices? Beautiful 6 factorial. Beautiful 720. Okay, this would have been a 3 factorial, 4 factorial, 6 factorial. Okay, so absolutely 100%, nothing new in the 3 examples that we've just done. Now, before we move on, I just want to scoot back up to the example with TEA. And we know that there are 6 answers. I want to go through what the 6 different letter arrangements would be. We could have TEA. We could have TAE. The letters could have come out like that. We could have had ETA, and we could have had EAT. The letters could have come out like that. We could have had ATE, and we could have had AET. Those are visually the 6 options that give you this beautiful answer of 6. Now, I'm not going to do it for carpet. I'm not going to list 24, and obviously I'm not going to list 720 different options. I thought a cup of tea, TEA, would be the easiest to look at. Okay, now, what if I change the letters from TEA, a cup of tea, to TEE, a golf tee? So again, I've got 3 separate wooden blocks. A wooden block with a T on it, a wooden block with an E on it, and a second wooden block with another E on it. And I'm thinking, geez, when I dump those into the bag and I shake, and I pull them out, how am I going to know which E I'm pulling out? So, you know what? I'm going to tell you, I decide to put a little blue sticker, any kind of sticker, okay? I put a little sticker on one of the E's when I drop it in the bag. Okay, so hold on, let's take a second and let's think about how they could come out of the bag as I'm pulling them out. It could come out, pull out T, pull out E with the blue sticker. It could come out, pull out T pull out E with the blue sticker, pull out E. It could come out, pull out E with the blue sticker, T and E. It could come out, pull out E, pull out T, pull out E with the blue sticker. It could come out, pull out E with the blue sticker, pull out E, pull out T. It could come out, pull out E with the blue sticker, pull out T. Again, 6 options because there were 3 letters in there. If the 3 letters were unique, the answer is 6. If the 3 letters are not unique, but with a repetition, I'm seeing 6 options, but I hope you're seeing what I'm seeing. Are you seeing that these 2 look identical? And are you seeing that these 2 look relatively identical? And are you seeing that these 2 look relatively identical? So let me give you the scenario. You put the letters in the bag. You put the T in the bag. You put the E in the bag. You put the E with the blue sticker in the bag. You shake, shake, shake up in the bag. And guess what? When you put your hand in to start pulling them out, the blue sticker has fallen off the block and it's stuck to the fabric at the bottom of the bag. So now what do you've got? You've got a scenario where these 2 look completely identical. These 2 look completely identical, and these 2 look completely identical. So therefore, your answer has to be 3. But wait a minute, when I had 3 unique letters, my answer was 6. So what we're going to do here is we're going to derive a formula that you use when objects are alike. And the formula goes like this. 3 factorial, all letters if unique, divided by 2 factorial, repeat letters. 6 over 2 gives us our beautiful answer of 3. So all letters, 1, 2, 3, as if they were unique, dividing out, pulling out, factoring out anything that is of repetition. Let's take a look at the word meat. Very similar to our second example, except in this one we mean like steak, and in this one we mean like a track meet. So if I follow my rule from the previous example, I look at it, it's a 4-letter question, 4 factorial, if all the letters were unique. However, I've got 2 repeating E's, so I'm going to factor out that part of the repetition. Okay, I'm going to pull out those repeat letters, the E's, and that's going to give me 12 different options. Okay, before we go to do 4, 5, 6, and 7, I want us to create a beautiful box. And inside this box, we're going to write the rule down. The number of ways n objects can be arranged if A is alike and B is alike. N factorial, that's the number of letters in the word if everything was unique, factoring out any letters of repetition. Now, you're probably wondering why I have 2, but keep that in mind when we look at examples 4, 5, 6, and 7. Okay, let me give you a moment to get that formula down, and then we're going to take a look at our next examples and continue with our note. Let's take a look at the word sass. If I'm following the rule says, take a look at the 4 letters as if they were unique, and factor out, divide out, pull out the repetition. So in that case, I have 3 S's that are repeating. 24 divided by 6 gives me 4 possibilities. And let's think about these we can actually think about and discuss. The possibilities would be SASS, SSAS, SSSA, and the final funny one, ASSS. Notice what's unique and what's different about these 4 different answers, 4 different options, is the positioning of the A. A is being positioned in the 2nd spot, the 3rd spot, the final spot, and the 1st spot. That's what's causing them to be unique, the positioning. Okay, how many different arrangements could we have in the word schooner? Well, hold on. 1, 2, 3, 4, 5, 6, 7, 8. So if the letters were unique, it would be an 8 factorial question. However, I've got 2 repeating O's. So 40,320 is 8 factorial divided by 2, 20,160. Okay, now keep in mind the formula with these 2 examples. So let's start with minimum. I've got 1, 2, 3, 4, 5, 6, 7 letters if the letters were unique. But in the word minimum, I've got 3 M's and I've got 2 I's. I can't group those together. It's not like there's 5 repeating letters. I can't put 5 factorial here. I have to keep them separate. I have 3 factorial for the M's, and I have 2 factorial for the I's. That's where this formula comes from. So again, please, please, please be aware, you cannot put 5 here. It's not like you have 5 letters repeating, the same letter repeating 5 times. You've got 3 M's and 2 I's. So 5,040 over 6, which is 3 factorial, times 2, gives me 420. How about you take a shot and try Mississippi with me now? Well, Mississippi has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if they were all unique. Let's be careful. 1, 2, 3, 4 factorial for the I's. 1, 2, 3, 4 factorial for the S's. 1, 2, 2 factorial for the P's. Now, this particular one you definitely won't be able to do on your calculator. So I'm going to have to take it in steps. 11 factorial is 39,916,800. 4 factorial is 24. 4 factorial is 24. And 2 factorial is 2. So 39,916,800 all over, when I multiply the 24, and the 2, 1152, 3465, or 650, 34,650. So we've just come up with our 3rd formula for the unit. And this deals with repeat objects. Now, we've only looked at repeat letters, but we're going to take it a step further and get into some harder examples as well. So when you're ready, do me a favor and we'll flip. Okay. There are 9 identical teddy bears lined up on a shelf. Okay. Okay, you can envision your bedroom with one of those floating shelves, and you're a collector of teddy bears, and you've got them all lined up beautifully on the shelf. 3 of the bears have a red bow. Okay, so 3 of the 9 have a little red bow. 4 of them have a little blue bow around their neck, and 2 of them have a yellow bow. So hold on, 3 have a red, 4 have a blue, and 2 have a yellow. Okay, there's my 9 teddy bears. How many unique ways can the bears be lined up on a shelf? So instead of me arranging letters that have repetition, I'm arranging bears that have repetition. So here's what I want you to envision. You envision that it's time to dust off the shelf. You take all your 9 bears off the shelf, and they're laying on the bed. So if they were unique, that would be a beautiful 9 factorial question, if they were unique. Because you would have 9 choices, 8 choices, 7, 6, 5, 4, 3, 2, 1, if you were lining them up on a lineup. But they're not unique. You've got to factor out that 3 of them are red and look identical. Everything's identical about them except the little red bow. 4 of them are identical and have a blue bow, and 2 of them are identical and have a yellow bow. So this is extremely similar to the letters question, except that we're dealing with objects that are identical. So 362,880, 6 times 24 times 2 gives me a beautiful 1,260. Okay, let's crank it up a little bit. How many unique ways can you arrange the bears on the shelf if there has to be a bear with the red bow at each end? Okay, hold on. Let me draw this out. 1, 2, 3, 4, 5, 6, 7, 8, 9. If there has to be a bear with a red bow on each end. This is the annoying child scenario. I decide when I clean off my shelf and my bears are sitting on the bed, I decide in my own mind, geez, it would look really cute to have a red bow bear here and a red bow bear there. So I place them first. They're placed and they're not moving. That means in this scenario, in the movable bears, I've got 7 factorial. 1, 2, 3, 4, 5, 6, 7. But inside those movable 7 bears, there's still 4 blue that are repeating and 2 yellow. I don't have to factor in the 1 red bear because, yes, there's 4 blue, 2 yellow, and 1 red, but the red isn't repeating. So this becomes a 7 factorial, 5,040 over 24 times 2, which is 48, gives me a beautiful 105 arrangements. So notice how I've pulled in annoying child concept with repetition, with objects that are alike. Okay? All right, can you please do me a favor and put a big star beside 9? 9 is one of these application questions. It's a special case scenario. It's very similar to the digits question, the harder digits questions from our permutation lesson. Okay, let's take a look at it. How many unique arrangements can be formed using the letters from the word silly? Now, when I say the letters, I mean all of the letters. So using all of the letters from the word silly. Well, let's think. 1, 2, 3, 4, 5. So if I'm using all of the letters and they were unique, this would be a 5 factorial scenario. 5 choices, 4 choices, 3, 2, and 1. 5 letters. but I've got a repeat of the L's, so I've got to factor that out. Again, keyword, I'm using all of the letters. Well, that isn't hard. That's just like Mississippi. That's just like minimum. That's just like schooner. That's just like meat. That's not hard at all. Here it comes. How many 3-letter arrangements could be made from the word silly? Okay, now I'm going to show you the wrong way. I'm going to show you, because if we were in class, we'd experiment with this. So your brain would naturally think this. Well, if I've got 5 letters in the bag, but I'm only making a 3-letter arrangement, 5 choices, 4 choices, 3 choices. Correct? And now I've got to pull out 2 for my L's. So if I left you to your own accord, which I normally do in the classroom, this is what almost 100% of you would do. And I'm going to tell you that it's wrong. This is a special case scenario type of question. Okay? So I'm going to tell you that this is incorrect. And I'm going to tell you that the real answer is 33. What? I got an answer of 30. And I'm being told the answer is 33? How come? Well, let me show you. You've got 3 different options actually here. 3 different cases, as I'll call them. You've got the scenario where your hand goes in and you pull out 3 letters and there's no L's. Or you've got the scenario where your hand goes in and you pull out 3 letters and you get 1 L. And you've also got the scenario where your hand goes in and you pull out 2 L's. Now, let me explain the logic. Let's jump back to here. If my hand goes in, think about the letters too. I'll make them big over here. If my hand goes in and on my picks, I don't pick out any L's, that means I've got 3 choices, S, I, or Y, 2 choices, and 1 choice. We also know that the word or means that. Okay. If I pick out one of the L's, and there's only 1 L, that means that I've got 3 choices here and 2 choices here. But what also has to be factored in is the ordering of the L. It could go L something something, it could go something L something, or it could go something something L. So I need to multiply that by 3. So the positioning of the L, where that one singular L landed, needs to be factored into the answer. Again, or means add. If I've got 2 L's, then that means for my 3rd position, I've got 3 choices, S, I, or Y. But again, the order of the L's, it could go L, L something. It could go L something L. Or it could go something L, L. Again, the positioning of that blank, or where the L's are going to go, leads me to another 3 options. It's like a permutation inside of a permutation. So hold on, let's look at what we've got here. 6 plus 18 plus 9, 24 and 9. Bingo bongo, we've got our answer of 33. Okay, very, very important. It's a special case scenario. Now, when does it happen? It happens when you have repeat letters and you're not using all of the letters. That's the trick. When you have repeat letters and you're not using all of the letters. One more time. When you have repeat letters and you're not using them all. Special case scenario. Okay, let's go on. Can we put a star beside 10? And can we put a star beside 11? Both of them a little bit more difficult, right? How many permutations of the letters school, S-C-H-O-O-L, have the O's adjacent? Well, let's take a look at this. Looks like I'm using all of the letters. It doesn't say anything about not using them all. And the word adjacent means together. And we've looked at that idea of together. So hold on, let me get the question visually set up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to put the O's together. And when I put them together, remember from our previous lesson, we group them together as if they're one. So instead of there being 1, 2, 3, 4, 5, 6, as soon as I group these guys together and they're considered one, there's 1, 2, 3, 4, 5. So if everything was unique, this would be a beautiful 5 factorial question. Now, let me show you what your brain would normally want to do. Your brain would normally want to do this because of the repeat letters. But you don't have to, because the O's are together. And your brain, as soon as you see the word together, would naturally want to do this. Think of the annoying boyfriend and girlfriend analogy. Boyfriend comes in first, girlfriend follows. Girlfriend comes in first, boyfriend follows. But in this case, you don't have to do this either, because the O's are identical. So this is one of these special case scenarios where, because the repeat letters are now together, there's no dividing them out, and because they're together but they're identical, there's no multiplying by 2 either. Special case scenario. Keep it in mind. Okay, let's take a look. How many 3-letter words can be used in the word athletic? 3-letter words. So they don't want me using all of the letters. They don't want me using all of the letters. And in the word athletic, I've got repeating T's. What does this remind you of? What does this remind you of? I'm hoping that out loud you're saying that to yourself right now. So this is the silly example. 3 scenarios: 0 T's, or 1 T, or 2 T's. 3 letters. 3 letters. Okay, now let's think about it. If there are no T's, that means that there are 1, 2, 3, 4, 5, 6 other letters, 5 other letters, and 4 other letters. If I get a scenario where there's 1 T, that means that I have 6 choices and 5 choices. But careful, 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 I've got to think about the order of the T's. T blank blank, blank T blank, blank blank T. So T, other letter, other letter, other letter T, other letter, other T. Order, super important. If there are 2 T's, then that leaves me with 6 options. But again, I've got to think of the order. T, T, other letter, T, other letter, T, other letter, T, T. Exact same example as silly, just a bigger word. 120 plus 90 plus 18, 228. I hope this helps. Thank you.